Dear aspirants, welcome to my channel. This is a model question paper 10 marks question. So there is a 10 marks question. The given problem, so we need to find out there is given bearings. Okay, bearings of the line is given and we need to find out the local attraction and correct the errors in a AB line and find the back bearing and interior angle of the given problem. See, we should know the local attraction in a closed towers, the forebearing and back bearing. We have to check the forebearing, back bearing. We need to find out the local attraction. So we have formula for that calculating local attraction. Local attraction free from. The back bearing is equal to forebearing plus or minus 180 degree. So it is given. The line AB, BC, everything is given. We have to calculate which is affected by the calculating first. We have to calculate the back bearing of the line. So here we are using the formula. Back bearing calculation is called forebearing plus or minus 180 degree. So it should be less than 180 degree. You have to plus, it should be more than the angle, the bearing of the angle, it is less than, this is also less than 180 degree, this is also less than 180 degree. We have added here, this is more than 180 degree, this is also more than 180 degree. We have did minus this table, you have to make it. Okay. After making calculating back bearing, we have to find out the local attraction. So first you have to having a local attraction. So in the point B, forebearing of AB is 240, back bearing of AB 240, forebearing of BC is 135. The difference between these two. So 240 minus 135, the difference it will not be equal to 180 degree. Okay, this is not equal to 180 degree. So the correction bearing method we have to use in the point B. Understood? If it is not, if you add all the bearings, that forebearing and back bearing of the line, if not equal to 180 degree, so there you have to check it. The first step we have to check the local attraction present at a point C, in the point C. So we have to go for back bearing of BC and forebearing of CD. It is not equal to 180 degree, that point we call it as a local attraction. If it is not equal to 180 degree, the local, it is affected by the local attraction, that you have to find out the difference between two. You will get a difference between these two, you will get the value of that. Above all you have to calculate like that only. Same way, coming to the point D, back bearing of CD 30 degree, forebearing of DA 310 degree. If you do minus between 310 minus 30, the difference should be, it is not equal to 180 degree and local attraction should be present. Here also local attraction should be present. Okay. Same way, go for B, forebearing and back bearing you have to check it. Okay. Forebearing and back bearing you have to check it. This is some value, it is changed. I see that it is not a 30 degree. I'll check once. Wait. Everything is correct. Okay. It is not equal to 180 degree. This is also not equal to 310 minus 30. If you do, it is not equal to 180. You will not get the 180 degree. Same way, these two difference if you do, it is not equal to 180 degree. So all stations finally concluded, all the stations should be affected by the local attraction. If the angle is not affected by the local attraction, means if you do the difference, you should get 180 degree. Understood this? Now we have to go for the correction, step for the correction method. So you have to assume the method. One station it is free from the local attraction, usually coming to the first station. So assume the first station, we are assuming all the station is affected by local attraction. But at that time what we have to do, we have to assume a station A is not affected by local attraction. Station AB is 60 degree. Understood? Station AB is an 60. So now we have to go for apply correction. We coming to the station B at a point B. Forebearing is 240. So back bearing is 240. The forebearing is 135. Understood? So you have to expected expected forebearing should be, we should get 240 minus 180 degree. If you get, you should get a 60 degree. But we got forebearing of BC is 135 degree. What you have to do? Correction for the bearing. So 60 degree minus 135 degree, if you do minus 75. So once you got the correction bearing, in that correction bearing you have to go for the observed forebearing. What you got it from observed forebearing, 135 degree minus 75 degree, you will get a corrected bearing if you do like this. Okay. Same way do it at point D. So back bearing of CD is equal to 60 plus 180 degree. You got to 240 degrees less than 180 degree. We have to add 180 less than 180 degree. So I have to add 180 degree. You got to 240. Observed bearing of CD, it is 310 degree. Expected DA we should get 240 minus 180, 60 degree you should get expected DA. Correction for D 60, whatever 60 you got and whatever observed you got, that you do minus 250 degree. The correction for DA is equal to 310 minus 250 degree. You will get a 60 degree angle for this. So local attraction is present in all the stations. The correction bearing of the lines all will be 60 degree. You can make a tabular column, otherwise what I did like that only you can do it, you will get the marks. So next question will be define contour. Draw a hypothetical contour, proper spacing of a steep slope, valley slope and pond and hill lock. Contour is an imaginary line joining with a reference point or datum, such as we call it as a mean sea level. So it is contour will represent a nature shape and ground surface of an earth, correct? Earth or map. Coming to the hypothetical contour proper spacing, it is a steep slope. It look like, say, this is the diagram will explain how the steep slope, and this is steep slope, this is gently slope. The contour, it is very close, it is very closed space, and it indicate rapid changes in elevation. It is a steeper slope. It will show the steeper slope for the steep slope of the contour map. Next diagram will be an rigid. So how it should be look like? It is an V shape downward direction, and it is having high and high land and crust will be there. This portion we call it as crust. We can use it for the rigid of the water flow. You can find out by using rigid. Next will be, this is valley. I have explained rigid. This is an valley. So how it look? Valley will be like this shape. Valley portion will be like this. So they represent plan and elevation, how it look like. Okay, so it is an V shape which is upward direction, a point showing in upward direction. It is indicate it will give the drainage path and lowland, and it is towards the valley. Water flows towards the valley portion of that. So this one is a pond or depression. This is called pond. The pond it look like. So it will give the closing circuit. It will show the closing circuit. See, it is showing closing circuits for inner hatches, and it is a low area surrounded with the high ground. It is low area surrounded with it. Is a water should be collected at the center portion of the valley. It is connected at the water. Next will be hillocks. How the hill and contours will be. It is very close to concentric. Number of concentric circles will be present. It is a center will be elevation towards the center. You just see the increasing elevation towards the center. It is an presenting a small hill portion. It is representing. And the contour never one extra point, contours never intersect each other. Space indicate the natural slope. It will give the close it hilly and depression. It is a very contour very close in hilly depression. I have above I have given, and V shape indicate valley and rigid. See more information, please subscribe my channel. So remaining questions I am going to upload next video. Thank you. So next the final question, why conducting chain survey you encounter the large pond obstacle measurement? Explain how it is overcome by obstacle, and can you justify any method. So in the chain survey, if you go for a pond, it is showing an obstacle, points will not be visible. It means, so you cannot see the station, aligned station. You can see cannot see pull the chain in the cross area of the water, right in the water. Okay. The efficiency we have to overcome, you can go for using geometric and principle, right angle triangle. We can go for this method. So this method we can use. You can perpendicular offset and rectangular method we can use. So based on a perpendicular offset method available and swing around the rectangular division, perpendicular offset method we can make the perpendicular extend erecting. Step by step you have to identify 2 points. AB survey line and pond falling point C and D point you can go for, and you can erect the both the side of the perpendicular of the point. So erect this, for example this is the pond, points will be there, both the side you can erect the perpendicular same distance of the pond. Okay, same way you can above you can draw a parallel line towards the erected points to the other side of the obstacle. You can clearly you can see, and by using at a point joining this you can determine the final value of the pond. Okay, we can determine by using method. And finally you can calculate the form of rectangular obstacle in the line CD is equal to EF. Nothing but I'll just draw. See, I'll just draw one line. You have to, this is the point. Let us consider, I just show you this is the point. So both the side you have to A, B point this side and CD. Let us consider this is A, B, C, D. Okay. So you have to erect E. This side you have to erect this side F point. Okay. So F point you can erect, and you by other side you can measure this parallel lines will be there. No, you can measure this parallel lines. What is the distance? You can measure and we can find the point distance. Here EF value will be equal to the CD value. Erect the points A and B station. This is the A station and B station. C, this is C, this is D, this is E, this is EF. If you know this value, you can calculate this will be equal to this, the length of the point, you can calculate it. So one more alternative method is called measuring EF, alternative Pythagoras method. We can use it for Pythagoras. So perpendicular C, so this is a line, this is C, this is E point. You can erect the point, okay, and erecting the point to measure the E and D distance. You can join these line, okay, D and E will be an join this line of the pond. This will be an pond. Okay, this pond. This will be an pond. Erect the line of the point. You have to calculate CD distance by using Pythagoras theorem. CD is equal to square root of E D square. Okay, D square minus of D square. You can calculate the Pythagoras, means it is CD is equal to square root of ED square minus ECE square. If you know the distance, you can calculate by using this method. So they are asking how a justification of the method. How you are going to justify it. I recommend here, we are recommend rectangular offset method. You are going to recommend it. So it is a direct method, converting inaccessible point in the direct horizontal measurements and reducing error compared to the trigonometrical calculation by using second method. So align integrity. So because you turn original line of AB at a point D, ensure that remaining straight line collinear, and advanced optical instrument we can use it for, like a theodolite you can use here. Simplicity nothing but it required a chain and simple tool setting, right angles, crash staff and optical square, and highly field calculations point measure issue. Okay, how you like that, you can justify this method. See more information and more videos this type of, please subscribe my channel and share and support. Thank you.